Welcome back. This is video 3. So we're still working on the back here. And we noticed just a moment ago that I have to go a fractional amount. So I know I'm here at x -3 and I need to go 1 and then another quarter, or 4/4 and then another quarter. So I'm going closer to the origin here. And so I'm really taking -3 plus 1 and 1/4. So when I think about that, I could do that in a calculator. And that would leave me with -3 plus 1.25 gives me -1.75. So if they showed the answer as a fraction, -1.75 would be -1 3/4. That's the same as 4, 5, 6, 7, -7/4. So this is the location of that point. And it gets a little sticky, but that's definitely what they've asked us to do there. Okay, next question. So we've answered this. What's the coordinate of r? We got -7/4. Wait. Oh, hold on. That'd be 4, 5, 6, 7. Yeah, -7/4, comma, 5/2. Again, if you struggle with this, it is multiple choice. So if you take 7 divided by 4 and you want to turn it into a decimal, just divide the two numbers and see how that number would be -1.75. And if you don't know what 5/2 is, you take 5 divided by 2. And you get 2.5. So maybe on multiple choice, this isn't your answer, but this is what you got. Then you'd work backwards and say, this is my answer right here. Now, let's keep going. Looking at question 37, we see EB is congruent to EC. EB is congruent to EC, given. Bam, bam. EF bisects AD. So that's interesting. They're trying to say that this whole segment here was cut in half by this. So we actually know that this section here is congruent to this section here because of that statement. Okay. Okay, now the reason why I'm not putting it on my picture is because it would put the two marks in the middle of the B, and that would maybe be confusing. Now it says AB is congruent to CD. So this little part on the end, is it congruent to this little part on the end? So working our way backwards, do we have enough evidence to figure it out, and what length would it be? Now notice there's nowhere where they gave us any angle evidence. So I'm pretty positive we can eliminate these. There's nowhere. Now we bisected, but notice we bisected a segment, not an angle. You don't see a little symbol here like an angle symbol. So I'm thinking it's side, 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 but let's walk through the logic. I know that this side, EF, is equal. So I'm going to put 4 marks there. So right now, if I have to compare this triangle with this triangle, I'd like to put marks there. Now let's think about this logically. Let's say this whole thing was 10, that'd be 5, and that'd be 5. Then they said these two numbers are the same. So let's say that's the number 2 and that's the number 2. Notice in a weird logical way, if I'm kind of figuring backwards, we don't know what this is, but we know it's the same number. We don't know what this is, but we know it's the same number here. So notice this segment BF would have to be 5 minus 2, and this would also have to be 5 minus 2. Whatever number it is minus the same number. So in a weird way, we do know that these segments are equal. So this is definitely side, side, side. congruence. Sweet. All right, next question. Moving right along. It says, I'm just going to fold my paper here. It says, in the triangle, E is the midpoint of BC. So that means this and this are equal because midpoint or bisect means to cut in two equal parts. Okay. Then they're saying D is the midpoint of this segment. So you should be noticing immediately that segment DE is called the mid-segment. That's a special case of a mommy and a baby, where we know this baby right here happens to be half the size of mom. Off to the side, if I drew mom, mom is BAC. And I know the baby is BDE. So we know that side BA is just twice as big as the baby. And this side, BE, BC would have to be twice as big. And so now they're saying to create a smaller triangle that's similar, the student uses this formula, and the student also notices that both the mommy and the baby have angle B. Why would we be able to say that these are similar? So notice this is, if this was 1, this would be twice as big. If this was 2, this would be 4, twice as big. So notice if I order mom and baby's side, least to greatest, baby, mom, their sides make the same ratio and the angles are congruent. That's definitely evidence of side angle side similarity. Cool. Let's take a look at 36. It says, triangle PQR has vertices at -3, -3, or excuse me, -3, +3, -3, -2, and -1, -2. Okay. So that's pretty cool. I'm just going to copy. Anytime I do transformations or translations, I like to copy down the coordinates so we can see where they're moving them. Okay. Now it says, what would the transformation make to be P prime, Q prime, and we need an R prime. And we know translation is rigid motion, meaning that this shape of this triangle doesn't move. It doesn't get bigger or smaller. So I'm noticing this looks too wide. And so I'm thinking R prime would be there. And I'm noticing I'm going over 2 and down 5, over 2 and down 5. And so this should make it make sense here. Okay, so it looks like R prime, and that's all they're asking for. The point of R prime would be 5, -2. Cool. But let's take a moment to review how coordinates change. So P prime, Q prime, R prime. We know in translation the X values here. So let's just take a look at P and P prime. P was over here. And then all of a sudden, now it's over here at 3, 3. So look, it looks like they added 6 to the X or moved it 6 to the right. 1, 2, 3, 4, 5, 6, 6 to the right. Okay, taking a look at Q prime, I'm at 3, -2. So 3, -2, once again, it looks like I moved 3 to the right. 1, 2, 3, 4, 5, 6. And then last, we should notice the same pattern, R. R was at -1, -2, and now we believe it's at 5, -2. So that makes sense. -1 plus 6 would be 5. Good job. Check out the last video for the last 2 questions.